All right, the standard for this week is comparing and combining data. So it's IOD 502, so that means that we need to look at two places. So first step always is read the question. Okay, and then you highlight the variables that it talks about. Then you go to the location that it says in the question. All right, and then you find those highlighted variables and compare your answers, or combine them, because it could be from two places. So, what does that actually look like? According to Table 2, so I'm going to look at Table 2. Okay, so this is where to go. If I underline it, that's going to be the variable to look at. Okay, so crustal diamonds are typically how much older than cratonic? Okay, so I'm going to go to Table 2. So I found Table 2. Now crustal and cratonic are my two variables here. Now here's my age, 1.3 to 3.5 and 0.2 to 0.5. So I'm going to make this a little timeline, okay? So I have 3.5 billion years ago, 1.3 billion years ago, 0.5 billion years ago, and 0.2 billion years ago. All right, now this is why this question is difficult. They say how much older, so there's two ranges here. This is the biggest difference they can have with each other, is 3.5 and 0.2 billion years, and that's a subtraction problem. And then this is the smallest distance that they can have, 1.3 and 0.5. So 1.3 minus 0.5 billion years ago, that is what? And if you're doing the math in your head, 13 minus 5 is 8, so you're going to get 0.8 billion years ago. Then if you're doing this subtraction, 3.5 to 0.2, right, you're going to get 3.3 billion years ago. So this is the age range. You're always going to have to do a little bit of math on this standard. So we have 0.8 and 3.3 billion years ago. That's our range. The reason why people get this one wrong is because you don't do the subtraction. So make a timeline if you can. Make a number line if you can, just so it's clearer. All right, number 2. Based on Figure 1. So where I'm going is Figure 1. The difference in temperature between the continental geotherm and the oceanic geotherm at 140 km. So the first thing I'm going to do is find a depth of 140 km, and I'm going to trace a line here. Now I'm going to find the difference between the continental and the oceanic. Continental, the temperature is, let's say, 1100-ish. Oceanic, the temperature is, let's say, 1500-ish, right? And now you're going to find the difference between those two. So compare, that's normally going to be a subtraction, and combine, that's normally going to be addition, just so you know for these standards. So 1500 minus 1100 is 400. So the answer to 2 is B. All right, number 3. The difference between the Mohs hardness, so I'm going to find Mohs hardness on my page, of graphite and diamond. So Mohs hardness is where I look in Table 1. And then what's the difference between those two? 10 minus 1.5 equals 8.5. So the answer to 3 is B. That one was pretty simple. Number 4. According to Table 2, so where I go is Table 2. Which type of diamond, so I'm going to look at type, is the oldest? All right, so I'm going to go to Table 2, and I'm going to find their age. So, Table 2, I've gone here. Then I'm going to be looking at the types of diamonds. And then I'm going to find the age. So this number is the biggest age in billions of years. Now I'm going to flip back. Before I do that, I'm going to find the biggest number here, and now what type of diamond that is. I've combined it with that section of the graph, and that gives me the answer, which is pre-solar. So the answer to number 4 is C. And our last question of the exit ticket today, number 5. According to table 1, which trial yielded the highest final velocity? So I'm looking at trials and final velocity at table 1. So I'm going to go to table 1, and then the highest final velocity, 2.9, 3.9, that one's highest. This is my highest value. Now I need to find the trial number, so this is adding that together. That's a combination one. Where did that go? And so the answer is trial 6. For number 5, the answer is D.